name is Scott Burst, and today we're going to introduce EC Park.
Our system consists of a mobile application, a website specifically for administrative use, and sensor towers placed at each parking space. This system allows students, guests, and faculty members to see the status of parking lots throughout the UCSC campus. When a car pulls into a parking space, an image is taken to check if the license plate and permit code of the car match a valid permit in the database of students and faculty members. If the car has permission to park in the space, the sensor tower will give the green light indicating you are authorized and good to go. On the administrative website, the authorized taken space will show up as a green dot, which can then be clicked on to view the name, student ID, license plate, permit code, and corresponding permission level of the student parked in the space.
In some instances, the user might have to rely on their mobile app to authenticate themselves. In this instance, the user is waiting to be authenticated, but they get a failure signal indicated by the red LED lights because the image recognition did not work properly. The administrator is notified of this, as the red dot indicates that the spot has been taken, but the user has not authenticated themselves. The user would use their mobile app to authenticate themselves. They would simply select the parking lot they're at and wait for the app to scan for nearby Bluetooth beacons. To claim the spot, they would simply select the Bluetooth beacon of their choice. Once the user has claimed the spot, the administrator will be notified accordingly. In this segment, we will discuss how the sensor box works. The sensor box always starts at sleep state. In sleep state, items such as Wi-Fi and Bluetooth are turned off. Every 4 seconds, an interrupt wakes up the sensor box. Once awake, the sensor box will detect if the status of the spot has changed. If so, the sensor box will turn on Wi-Fi and connect to a gateway via TCP. In addition, the Bluetooth beacon will turn on if the sensor box detects the status of the spot is taken. Once connected to the gateway, the sensor box will send a message with the updated spot status. The gateway can then send a variety of messages, such as to take a picture, authorize a spot, or deny a spot. Once it receives an authorization or deny command, the sensor box will display green or red LED patterns for 4 seconds before going to sleep.
A Raspberry Pi acts as our gateway, which adds scalability to the parking system by buffering and relaying messages from multiple sensor towers to the database. Once a car pulls into a space, the sensor tower connects to the gateway's Wi-Fi hotspot, sending status data and the photo over TCP sockets. Once the photo is received by the gateway, using computer vision, it scans the photo looking for a license plate number and a QR permit, and buffers those credentials before sending it off to the database. The database then checks the credentials corresponding to the unique QR permit and license plate number to see if they are authorized to park in the spot, and returns an authorized or denial signal to the gateway, which is then forwarded to the corresponding sensor tower.
The mobile app serves as a tool for the user to authenticate themselves or to check for parking lot occupancy percentages. If the user is a registered student, they can simply log in using their student ID and Blue password. If the user enters the wrong credentials, the app will notify them with an alert screen. Once the user enters their correct credentials, the app will redirect them to the parking lots page, where they can look for the parking lot occupancy percentages for each lot. To authenticate themselves, they would simply click the parking lot that they're in and then wait for the app to scan for nearby Bluetooth beacons.
Functionality on the administrative web app includes a dashboard highlighting today's flow of parking, as well as an overview of how full each lot is. Statistics for any parking lot can be viewed individually, showing the trend of parking over a whole week, broken down by the hour, or for a specific day of their choosing. Registering a new student is easy, requiring only their name, license plate number, student ID, and the duration of time their permit is valid for. And creating a permit for any student can be done by supplying their first name, last name, and student ID number. Finally, the Google Cloud acts as the central node that connects all of the aforementioned components of our system together. Specialized APIs were created for use from the gateway, administrative web app, and the mobile application. Through these APIs, gateways can keep the status of all the parking lots on campus updated. Administrators can track who and where illegally parked cars are, register new students and give them a unique parking permit, and track the current flow of students coming in and out of parking lots throughout a day, as well as spot trends over a whole quarter or year. Mobile application users can log in if they're students or register if they're guests. They can then view how full individual lots are and authenticate themselves should something go wrong with our computer vision.